Hi, I'm Garrett with IDC Woodcraft, and welcome, the beginner CNC router person who's learning stuff. You're about to learn about drilling on a CNC, and this information is going to take you kind of out of the beginner stage and more into an advanced or intermediate stage in your mindset. So this is a good video to watch. It'll also give you tips about routing. You'll be able to just like take this stuff to the next level. So here we go. Drilling on a CNC. There actually aren't very many videos out there for that. So I am going to talk about it. I'm going to talk about the actual drilling process and do you really want to drill on a CNC, the tools you should use, and we're going to talk about spiral drilling, which is my preferred method. So let's just kind of dive into this. First of all, drilling on a CNC. Should you do it? Well, it's okay in certain circumstances with certain bits. I really want to get this basic information to you so you really understand the risks of drilling on a CNC router. Okay, so you have, or we have, a drill bit right here, and it's not focusing, but that's okay. You understand that drill bits have a tapered point, 118 degrees to be exact. But the reason for that point is as the drill is plunging down, first of all, you have the point to guide the drill and keep it on center. And then the angle drives the chips out and up into the flutes or the spiral of the drill. And that's why a drill is a drill. On the other hand, here we have a spiral bit, and you can see that the blade virtually goes across the entire thing. You can see there's a bevel cut right there, so it goes right into a point. This one is going to function as a drill fairly well. The problem is it doesn't have a point to guide it, and so when you are actually trying to drill with an end mill and you're coming down, it really doesn't have its guide, so it is going to start to want to walk. And it may either start doing this thing or it's just going to start going at an angle. The other thing about these guys is there's essentially a shaft going down the middle of that. And this little center area right there, when it's plunging into your material, it's actually acting like the shaft. It's very dead nut center. That little spot is where material does not want to move away. It'll show up on your wood. You'll see that little circular mark that you've seen in holes before. And that's an area where pressure is being applied against the tool and therefore throwing heat into the tool. Now you have other ones like this, which are very hard to zoom in on. But you can see there is a shaft on this one. It has the cutting edge. It kind of comes halfway offset. There's one over there. It kind of comes halfway offset. And there's a bevel there to create that. But then it comes out to the shaft of the tool. You can see about a third of this is taken up by the blade, and then or the blades, and the rest of it is basically a shaft. The same thing is here. The other thing I want to talk to you about is tendency of the chips. Now the chips will want to ride up the flutes as the tool is spinning like that. The chips are going to want to go up that way, but there's only so much that can go up through there, so you have to peck drill if you're drilling. Now the one thing I want to point out as I'm talking about that, with routers, if you're drilling, you absolutely want to use a peck drill cycle. All CAM softwares have peck drills, CAD CAMs have peck drill functions. And you want to keep your peck distance short, and you want to retract to the start position. You'll always have the option of retracting just above the last cut, then start to plunge again, or retract all the way out of the material. And you want to retract all the way out of the material to clear up the chips that build up on your flutes. Now here's another tool, and this is a $30 bits and bits down bit. Okay, so as it's turning, the flutes are going down. Do not ever, ever, ever use a down bit when you're drilling a hole, because all it's doing is pushing the chips down in a hole and they're going to compact down at the bottom. But that's one of the things. One of the other things I want to point out, though, too, is if you notice on the end of this bit, you can see it's actually in like a reverse V shape there. This is not good for drilling at all, and it's not set up to drill. Being a down bit, it doesn't really have a cutting edge at the bottom. You never want to use a down bit for the two reasons I just stated. You'll run all your chips down, they'll compact in the hole, and it will bounce around horribly, and you really run the risk of breaking your tool and ruining your hole. Like I did on this sign. You can see I've got a nice clean hole right here, and these two holes are nice and clean, but look at that one. All chewed up. Because I did a plunge drill with a 1/4-inch bit, and the chips didn't give way. So that's why you want a peck drill. Be very aware of the tool you're using. I wasn't using that end mill, by the way. I was using like a cheaper version. Now I want to talk to you about spiral drilling. Now, what is spiral drilling? Well, this is spiral drilling. You're watching an 1/8-inch diameter router bit plunging down into a hole. That's going in a corkscrew motion until it gets to the bottom of the hole. Now let's look at it again from a different angle so you can watch this. And you can see the chips are all ejecting very nicely. There's plenty of room for them to go out. You will get a very clean hole here by doing this method. So when would you use spiral drilling? Well, pretty much all the time. At least that's what I like to do. Rarely I'll plunge drill or I'll just peck drill. Usually on very thin items. If I'm going deep, I want to get a lot of clearance. So when you have a flat bottom tool, you know, you're asking for trouble, as I explained. As I've had a lot of machining history, and I can tell you, we don't drill holes with a flat bottom tool except in very special cases. So what I'm going to do is I'm going to go into VCarve, my CAD/CAM program. You as a beginner, CAD is computer-aided design, CAM is computer-aided machining. So we're talking about CNC routers and the software that generates the drawings and the G-code. So the CAD part is the drawing part. The CAM part is the part that's generating the code to actually run your machine. So you have CAD/CAM software. Your software has the capability of what my software does. So even if you don't have the exact same buttons, you know, the concepts are all still going to be there. What I'm going to do is I am going to show you a peck drilling cycle. And I'm going to show you also like an odd size hole. So this is one of the other cases where you really want to consider this. If you have an oddball size hole that you have to drill, then none of your router bits are going to make it. You're going to have to do some other technique. Now I'm going to explain that as I go into this with VCarve. Before we do that, I want to ask you a favor. If you're finding this information useful, giving you new knowledge, will give you the capability to become a better CNC router specialist, whatever you're going to be doing, please give this a thumbs up. This is my gauge as to whether I am giving good content or not. And it's even more helpful if you give a comment and recommend things that you'd like me to talk about. I've got a few on the table already that a few guys have asked for, like JC has, and I can't remember the other one. I got a list of videos I have to make. Anyway, I don't want to waste any more time. Let's dive into VCarve. All right, we are in VCarve and we have a part set up. So I'm going to draw several circles here. The first one is going to be 0.125 or 1/8 of an inch in diameter. The next one is going to be 0.25, and we're going to draw 3 of those. 1, 2, 3. And we're going to walk through the drilling techniques, and that's going to make this video just a little bit longer. I apologize, but I want to make sure you understand all the different techniques that you can use in drilling in your software. So, first of all, we are going to do everything with an 1/8-inch end mill or router bit. Spiral, mind you. Don't use a straight router bit in a CNC router. All right, so the first thing we're going to do is go into peck drilling. I'm going to open that up, and we are going to go for all these jobs through the part. I'm going to select that item, and we are set to go through the part. The tool we've selected is the 1/8 inch end mill router bit, and I'm going to leave the default settings as they are in the tooling library. Now in Peck Drilling, we are going to use Peck Drilling. We're going to check that, and then we're going to retract above the cutting start depth. That pulls the tool above the surface of the material so the chips can clear off the tool. The other option is retract above the height of the previous peck. So what that means is it's just going to come up to where it started at from the previous point and go back down. Basically, it won't pull out of your part. That's not a good way to do it because your chips won't eject out of, won't have the clearance to get it out of the tool, especially if your flutes don't have enough room to allow those chips to get out. So we are not going to use the dwell function. Dwell means it's going to stay there at the bottom of the hole briefly. And we're not going to use any other settings, and we're just going to calculate that. And let's take a look at the tool path that it generated. So the red line is the rapid over to the position, and then the green line are the feed plunge rates down into the part. And excuse me. So it's going to plunge down, and then you can't see it, but there's a little bit of a blue line in each one of these. So it's going to plunge feed down to where it's going to start pecking, and then it's going to start to go into its normal feed rate. And then it's going to pull back up to this point right here every time. Very important to do if you use a peck and drill cycle. So that's that. I'm going to show you the time differences on these as well. But let's go to a 1/4 inch hole. Now you know that with the 1/8 inch tool, that's half of the 1/4 inch diameter. So we can get a good clearing out of that hole using that 1/8 inch router bit. So now we are going to use the pocketing tool path. And I'm going to select that 0.25 inch hole. By the way, if you try to pocket an 1/8 inch hole with a 1/8 inch bit, the software won't let you do that because it can't do a side-to-side profile, which is what a pocketing does. Okay, again, we're going through the part. We have our 1/8 inch diameter selected, and it is taking 7 passes. So what it's going to do, it's going to come down, well, let's just calculate it out, and I'll show you. And I'm not going to do this with a ramp in function. So we calculate that out. And let's take a look at this tool path now. So what you're seeing are 2 blue circles. And this circle, the inner circle, is kind of interesting. The reason it's creating 2 circles is because the tool in the tool library has a step over setting. And the step over means the percentage of the diameter of the tool that is going to step over from center line to start doing its cuts. So you can see this is doing 7 passes, and for each pass it comes down into it feeds down to the first circle. It interpolates around. Interpolate is an interesting word, but that's the word they use in machining. And interpolate basically means transforming from one thing to another. So we're transforming from nothing to a whole. It's going to circle around that hole, and then it's going to move out, and it's going to do the bigger one, and then it's going to come back to center, come back down, and go down for every step distance that it's set to do. And when everything is done, you have a finished hole. And if we preview that, you can see what it does. Let's just shorten that time frame a little bit, reset that so you can see what the tool is doing. I'm going to shorten it up a little bit more and see if this thing can generate this the way I want it to. There you go. Now you can see it. Okay. All right. Next is we are going to do the pocket command. Now we're going to do the profile, the 2D profile toolpath. Again, we're going through the part, we're using 1/8 inch, and you can see the passes are different. It's 5 as opposed to 7. And that's by default of the settings of the tool and however the program generates it. Now I'm going to select inside because I want to do inside the hole, and we're going to select the next hole. And now we are going to run this part as it is without any ramps or anything, and we'll take a look at what that tool path looks like. So what happens now is the tool comes down to the side of the hole, interpolates around, comes down to the next one, interpolates around, down, 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 until it's done. And let's generate that one. Okay, that was much faster. Now we're going to do the spiral drilling. This is where you want to really take this into account for any kind of hole. Spiral drilling is beautiful because you can set your diameter to any size hole. You can be very controlled with it and be very precise with it. I really prefer using this. We're going to go in 2D profile toolpath again. All the settings are defaulted into the material depth, the tool, the settings there. So we are going to do adding ramps. Now I'm going to do 2 ramps here because I want you to see the difference. First we're going to do a smooth ramp. And we're going to generate that real quick. We're going to select this last hole and generate this toolpath. Okay, now you see something kind of interesting. What this is now doing is it's plunging down into the part in a corkscrew fashion. And it gets to the first depth of cut. The depth of cut is the, again, it's in the settings. It'll come down to that depth, it'll do its job, and then it'll come down to the next depth. So what this does is it circles around into the part down to the level that it wants to cut, and then it circles around, and then it corkscrews down again, and it keeps doing that until it gets to the bottom and it makes its final interpolation. So before we move on, I want you to take a look at the times of these. So the first one is the drill. The Peck Drilling takes 20 seconds. The second one, the pocketing command, this one right here where it has to do 2 times for each hole, takes 49 seconds. The third one, which is the profile tool path, where it just comes straight down and does an interpolation, straight down interpolation, takes 7 seconds. And the final one, this corkscrew, where it comes down and then circles around and then corkscrews again, takes 12 seconds. So what I'm going to do is I'm going to copy this final circle here. Because I want to make sure we see the last one. And it's not going to let me when I'm in this setting, so I have to switch over. And now we're going to pick it again and Control Shift if it's going to let me grab it. For some reason it's not letting me do this. We'll do it one more time. Sorry that this is taking a couple extra seconds to do this. Okay, well we're just going to go back to the longest tool path, which was pocket 1. So I'm going to go back into pocket 1, which is this guy. You already see that doing a pocket command is not going to work here. So I'm going to go back into that, and I'm going to change all my settings. What I'm going to do is I'm going to delete that one. I don't want that. Sorry. We want to go into a 2D profile. So I'm just going to add this one and start it over again. We are going to select that hole. We have it selected. And all the settings are the same. Now we're going to go back down to our ramp. We're going to turn the ramp on, and we're going to do a spiral cut as opposed to a smooth cut using the tool settings. Now I'm going to turn off that one so you can see. Now look at the difference. The tool virtually spirals all the way down into the part until it gets down to the bottom. And this is an excellent way to get a nice clean cut all the way down. It's done in one tool path. And let's take a look at the timing for that. So that is going to be this one right here. We turn the other one off because we can turn it back on for the timing cycle. And you can see that takes about 10 seconds, a little bit longer than the step down method using the profile toolpath without any ramping. So I want to turn that back off. The problem with this one right here, where it doesn't ramp in a spiral, is you end up with a notch all the way down the side of the hole. And that can be a problem because the tool stops there, then it plunges down and starts over. So the tool just ends up rubbing right there. So you'll have just some kind of strange thing. Here you don't have that. It's just a continuous tool path. So that's how you set up a spiral drill. And there you have it. You understand how to peck drill, spiral drill in. You understand the nuances of all that. And I want to thank you for hanging around. I know this has been a long video, but I want to relay as much information to you as I can. If you find this video useful, like I asked you before, please just give me a thumbs up and perhaps a comment. And that way this video will rank and other people like you who are beginner CNCers will be able to get this information. And it'll help my channel grow at the same time. So you've learned some advanced stuff actually in this as a basic CNCer, which is going to take you a notch above a lot of other people who do CNC work, enable you to do a lot of other things. If you have any other issues, just give me a comment. There's a lot of links down below, the types of tooling that you need to get as a beginner, other resources, and how to start a business on the internet. If you're doing CNC routing and you want to start a business, you have to create the business platform. And online is the way to go. Anyway, I'm said enough. This video has been very long. Thank you for hanging around. I hope you have an awesome day, and we will talk to you next time. Oh, don't forget to subscribe.